Welcome everybody to this new episode in our webinar series. The topic today is automatic machine learning, automated machine learning, and in particular, it's a blueprint that Paolo, Simone, and Christian put together a few months ago. Paolo will show us today what are the steps involved in an automated machine learning application and how they have implemented them in KNIME. Paolo here is a data scientist at KNIME, and he's our in-house data visualization expert. Please write your questions in the chat. And Paolo, please.
Yeah, hey everyone. I will share the screen a second. All right. Okay, so here we start. I would like to start from a quite popular diagram when we think about making machine learning models. So this is the cross-industry standardized process for data mining. Some of you might know, who of you know this diagram? So basically, when you make a machine learning model, you go through the steps. And the point of this cycle is that shows the iterative process of this process, right? So what I mean is that often you will need to go to a previous step and change something that was not working and then try again. And by repeating those steps, in the end, you will reach to a model that is good enough to deploy. So basically, by using this process here, you produce a framework. And when you do this with the KNIME Analytics platform, you create a KNIME workflow. So in theory, how this would look like is a data scientist that is creating this KNIME workflow. And you can recognize here the same steps of the CRISP DM: load data, clean transform data, analyze, and then finally visualize and deploy. So the point is that the data scientist is having this solution and is showing this to the business analyst, and in theory, we reach a solution and everything is perfect. But in practice, this is not what happens. Because often the business analyst has some domain knowledge that the data scientist is lacking, and he might propose something to change to the KNIME workflow, to the framework that has been built to deliver this machine learning model. So what you could have is a question like, can I use a neural network instead? Can I upload a different file? Or can I optimize the model parameters? And in a different way, for example, about creating a new column using a different feature engineering technique. So all of those questions are totally fine because the business analyst needs to give his input. But this is time consuming because every time data scientists need to change, see what's feasible, take some time, and then present it again, and some new question will rise up. And all this back and forth will take some time, right? So a solution to this that we have in KNIME is actually to use wrap and meta nodes. So basically, those gray nodes you see here are able to create an interaction that the business analyst can use to right away change what he wants to change in the process. So to be more precise, just take this example. So we have load data, where a web page is created that makes the business analyst able to upload a different file. Or you have clean and transform data, where the business analyst can define a different time range that all of those are parameters that will change what the nodes are doing now. And visualize, we can create interactive dashboard that the business analyst can play with to understand new things, and for example, download right away the new predictions. So how do we do those wrap and meta nodes? Well, in KNIME, it's often all about nodes, right? We have those two nodes categories. The first one is the quick form nodes, right? Those are creating those interaction that can be used to change the parameters in a node via flow variables. And then we have the JavaScript nodes, which basically use D3 visualization, which are interactive. and can be used to better understand the data. So the way it works then is that by having those nodes, you select them, you right-click them, and then you have this tooltip, and you can say encapsulate into wrap meta node. And then you have this meta node that will create a view. Let's be more precise here. So when you have a quick form or a JavaScript node inside a wrapper meta node, you create an interactive view in the KNIME Analytics platform. That is a window that is popping up, and you can interact with it. And it's basically a web page in the embed browser of KNIME. But when you're using the KNIME server, the workflow is deployed on the KNIME server and is accessible via KNIME web portal. And all those web pages you create are accessible via a link. So that means that the business analyst can access those web pages without having installed the KNIME Analytics platform. So the way this works then, that when you have multiple quick form and JavaScript nodes, you produce a composite view, right? Because you have different elements that compose this dashboard, this web page. And you need to style the layout of how those different elements fit together in the web page. And this is possible via this button. So I'm showing here the toolbar that you have in KNIME, and here to the far right, you have the layout button. You click this button here, and you will have this panel coming up where you can drag the different node representation, the different view representation, so that it's really user-friendly to come out with a final page and with exactly what you wanted to have the view with this grid layout. So next, we should see exactly how we build those wrapper meta nodes. So if you double click on a wrapper meta node, you open it, and inside you have a portion of the workflow, right? And this version of workflow is made of different nodes. In this case, we are using a file reader and an Excel reader, and we join those two tables together. But let's say the domain expert, the business analyst wants to change the Excel file. So you will need to add the quick form node that via flow variable will be able to change the upload of the Excel file. So this is an example. Another example is, for example, those interactive dashboards you can create with the JavaScript nodes. So those JavaScript nodes are interactive by themselves, meaning that you can change certain things right away. But by basically just dragging those nodes and connecting them, the interaction also happens between different charts, meaning that if you select a data point in a chart, a row, for example, in the scatter plot, this selection is also propagated to the other view, and it's all automatic. So it's quite easy to set up and to use. Okay, so this is first example on how we build all of this. But now we have all the ingredients to speak more about this process, right? Which is what we call guided analytics, right? We are developing interactive system for the business analyst to basically finding new insight and using those predictions to understand better the business problem. And it's all interactive and made with KNIME. But today, the webinar is not about guided analytics. Today, the webinar is about guided automation, which is a special instance of guided analytics. And we are aiming at intelligently automating the machine learning cycle. So we are doing this in an intelligent way. This means that we are not just automating everything. We want to use the domain expertise of the business analyst when it's useful, and to automate when actually the business analyst doesn't want to put his input in a certain part of the process. And that is usually when you just need to try many different combinations of hyperparameters, of features, that is a set of different columns. And that is a good way to optimize the machine learning model, but is also time consuming. So we want to automate part. Two key questions here. Can we automate the machine learning cycle in KNIME? And is it useful to automate the machine learning cycle? So the first question here, yes, we can, and we develop a blueprint that we'll show to you that shows you how to do this in KNIME. Is it useful? That is a more tricky question because it depends. For some problem, it's useful because it works perfectly. In some other problems, you need to use a customization. And that is that the blueprint we made is actually, you have the ability to customize it. So this is the general recipe to automate the machine learning cycle using guided automation. We have a first part where we are going to upload different data files, connect to a database or to a cloud. And here we are going to blend the data, right? Depending on what you have connected. And that's where the part that is customizable is, it's really important to have this custom part. But then we set up for you this human interaction part, which is basically web pages that ask to the business analyst important questions like, what do you want to predict? Or what columns do you want to use for this model? And so on. And finally, when we have all these settings ready, we are going to automate the machine learning training and testing. And all of this is automated, and it's related to this part right here. And it also can scale and use a big data platform like Spark. And finally, we have the dashboard where you can finally see all the results and see the performance of the different models and so on. So this page right here, we are going to see how it looks like in the end, but let's spend a bit more time on how all this automation takes place. So we have the business analyst that define all settings and selected a certain amount of columns to be used by the model. And we go through those steps, which is data preparation, where we handle the missing values. And if requested by the business analyst, it will remove outliers. And then, for example, we also normalize the data when needed. Then we do the feature engineering part, which is where we are going to create new features from the existing ones. And it is also that now in this way we have many features. So the next part is to optimize both the hyperparameters and all those different features, that is columns that we created to find to optimize the best column set we can find and the best parameters for the model. Finally, we retrain on the entire train set, and then we perform a model evaluation on the test set, and then we have everything we need to create the final dashboard. Okay, so this is how the automation takes place. But what about the human interaction part? So now we are going to see the user interaction part on the KNIME web portal. That is, we have the KNIME workflow that is deployed on the KNIME server, and we're going to see it like a live demo. Okay.
Okay, so now I will play the role of the end user, and I will go through this blueprint from a web browser. I am now on the KNIME web portal. I already logged in, and this is the blueprint workflow. Okay, so this application was developed by Paolo, Simone, and Christian, and it's really nice because it walks you step by step. So the first step is to upload the file. Now, the default file is the adult data set. It's a small data set. And of course, since I have to give a demo now on my local machine, I cannot exaggerate with the size of the data set. So I will keep the adult data set. But if I want to change the file, of course, I can go through this button, and then I can upload another file and do maybe something more meaningful. But for this demo, let's continue like that. Okay, so now we have chosen the file. We select next. So the adult data set is a relatively old data set, contains, I think, 30,000 records or something like that of the US Census. Each record is a person, and they are described via occupation, education, income, relationship status, and stuff like that. Here there is a summary of the data set. We want to predict the income. That's our goal for this little demonstration. And the income has been renamed as label. So just to make sure that the Rosaria doesn't make any mistake. Okay, so now let's select next. So the income, poor or rich, is what we want to predict given all the other information. Now, the third step is to perform some column filtering. So I can remove some of the columns based on a relevance measure here, right? Or I can remove them manually because I have some previous expertise and I know that, for example, age is not important or something like that. Let's go back a moment to the relevance measure. Here I have a slider. For example, if I move to, if I want a relevance measure at least of 72%, then I end up with only 2 columns. Of course, that's a bit not enough for all these, for this small data set. So let's stay with, let's keep a few more columns, okay? So I keep a relevance threshold of 10%, and I'm going to keep all these columns for the training of the model. Okay, then again. Okay, so now this requirement, we need to select the models. So we have a number of models that are already pre-packaged to train. So I can accept the default. For example, I can remove the deep learning because maybe it takes too long, or I don't know, I can decide to have some models or some others. This flag here allows me to customize the fine-tuning of the model parameters. If I enable this flag, I'm going to have 2 additional optional steps where I can customize the whole fine-tuning part. If I leave it unflagged, then there is going to be an automatic fine-tuning process, which I cannot do anything about, but it's going to perform some basic fine-tuning for the model as well. And then finally, I can decide if I want to automatically remove the outliers. I would like to spend a few words here on the frame of this page. So on the top, you find the navigation bar, and you can see that those are all the steps that we have to go through. The yellow ones are the ones that we already covered, and the gray ones are the steps that we still have to cover. So here, as you see, we are at a bifurcation, at an intersection, and this depends on this flag here. So if I decide to customize the fine-tuning of the model parameters, then I'm going to go through these 2 additional steps. Otherwise, I'm going to bypass it, and that's what I'm going to do here. If any of the steps is not clear which kind of decision I have to make, then you have here this little description, these short descriptions of what the questions, the decisions, and these steps are. Okay, so you can spend a bit of time investigating if you are not sure. Okay. And then the final step here, before we start with the training, is the execution platform. Here I have 2 options. Actually, I have only one at the moment, which is the local execution on my local machine. But if I were in a more sophisticated environment, then I could connect to a Spark cluster and then run my whole execution on the Spark cluster. Okay, so at this point, I would press next, and then the whole training starts. Now I'm going to do like in the cooking shows. And I'm going to start the cooking and show you the results from a previous experiment. This page is going to show the performance of already trained algorithm, of already trained models. It's going to be a big page, so I'm not going to describe everything. I'm going just to give you a little taste of what is contained in there.
Right now, it's computing feature importance metrics for machine learning interpretability and other charts that are advanced. And that's why it's taking a bit of time. Here we go.
Okay. So here, the accuracy and the area under the curve of all the models are reported. Since the data set was small, all the accuracies are relatively similar, independent, so not that much depending on the model, but that's because the data set was tiny. After that, we are going to have a bar chart with the speeds of the different training times, with the different training times and the different prediction times. So here we have the training times. We see that the random forest is the one with the longest training time of the models that we have chosen. And here we have the prediction time per sample. Okay. We have an ROC curve to compare the performance of the different models. And then, of course, at the end, once you have viewed all the performance, you have seen the speed, you have got an idea of what your best model is, you can decide, for example, that you want to download the decision tree. And with this button, you download the full workflow with the trained model. So, and the same here, you can download, if you are not decided, you can download another one, and then you're going to have also the workflow with the full trained random forest model. Okay, if you are still not convinced and you want to go into more details about the quality of the model and the speed, the execution speed of the model, then you can scroll down to the advanced assessment section, and then here you have even more information about the precision, the recall, the cumulative gain chart, the feature importance, and the confusion metrics, and that's for each one of the model that you have chosen. Okay, so this was just a little taste of what this blueprint can do. So now I'm finished. Paolo, you can continue.
Yes, hang on a second. All right. So this was what you could see from the interaction point of view, right? That's what the business analyst sees. But what about the workflow that is running on the KNIME server that we use to create those pages? Well, that's how it looks like. As you can see, all those light gray nodes are the ones that create those web pages. It's quite big, but don't worry, we're going to go through it. So basically, the first part is where you define the settings. So the first node is the upload data set, and this will create the first page where we actually upload. And then from here, the data flow starts. So next, we are going to select the target that we want to predict. So that's the other wrap and meta node. And once we know what we want to predict, there is the feature quality calculation. In this step right here, we are going to compute the relevance, right? We're going to compute how many missing values, how many constant values, how many unique values, correlation, and all of this is needed for the next page, where we move the slider and we decide what to exclude, include, depending on all those quality measures. Okay, so the next step then is to decide the different models, right? And also whether you want to fine-tune the model parameters or not, and the outliers removal. So let's see what happens once, for example, we want to also fine-tune the customization of the model parameters. So that's where the branching happens, right? Because on the lower branch here, we're going to do this automatically, and that's what Rosaria did before in the KNIME web portal. We just skip those 2 pages. But if we do not skip them, what we have is those range slider. Here we decide how big will be the search of hyperparameters. And you fix those lower and upper bounds that will, in the end, define how many hyperparameters you're testing. Then next, we have the feature engineering settings. Here we decide what are the transformation we apply to the features. We have a simple transformation like the logarithmic function, or also feature combination, where we do just arithmetical operation between two features. And then we have the dimensionality reduction, like, for example, PCA. And there is also other ones, and you can decide which one to use. And of course, the more complex stuff you choose, the longer you will need to wait, and the more computation expensive it will be. And then that's why it's important, this last node, which defines if you want to execute this computation on a big data platform or just locally. Let's go next. And this is where all that automation takes place, right? Because now we have everything we need to start the optimization of the models. We know which models we want to use, right? Which algorithms. Then we know the target variable that we want to use. We know like the settings on where to execute it, whether we want to do a type of feature engineering or another. And all of this happens here. And once we evaluate all our models, we can create this final dashboard. The final dashboard will then be executed by this last wrapper meta node, which has also those download buttons to get the final workflows to deploy and to finally get to the final solution, which is to have a machine learning model where you can score new data. So this is the blueprint we designed. And next, what you should do at this point is to actually use and try this blueprint yourself, because it is available online, of course, for free on the example server. This is the path. You just need to connect and download it and use it and customize it to your needs. And it's really, all this framework is really open for you. One more thing. Now, yes, what we think that ideally the way should go now, that the data scientist can relax a bit more and that the business analyst is a bit more independent when using the interactive system to create machine learning models. So I would like to also say we have a new Learnathon coming up. It's called the Guided Analytics Learnathon, and we basically show how to create those wrapper meta nodes, and we divide people into groups to be able to create this kind of workflow. And the first of this Learnathon will be in Paris, and next month. So if you are in Paris or you're able to be in Paris, come and join us. If you want to know more about guided automation KNIME in general, we also have a big event coming up, which is the KNIME Spring Summit. This will take place in Berlin, in the Berlin Congress Center between March 18th and March 22nd. Monday and Tuesday, we will have one-day courses, and then Wednesday and Thursday, the summit sessions, where people actually show how they use KNIME in their business, which I find quite interesting. So Friday, we also have workshops, and what you should know that if you register before February 4th, there is a 20% off discount. All right, so thank you for joining the webinar. As a gift for you, we have this digital book, which is for you free to download if you use Guided Automation 0119 code. And back to Rosaria.
Okay, so here we have a few questions. Can you unshare?
We unshare and go on a second.
Okay, so here we got a few questions. So the first question is, that's for you. I don't have a license for the server, so can these nodes run locally on the KNIME Analytics platform? I understand the web portal is part of the KNIME server. Do I have to change the blueprint if I want to run it on KNIME Analytics platform?
No, it works completely. The only thing you need to do is to right-click and then you open the view. Then you interact with it, and then on the window you have on the bottom corner, you just need to apply the settings, then close, and then you will have the settings applied to the workflow. So you can totally run this locally and also connect to a Spark cluster if you have one. You don't need a server to automate this and use the workflow. Yeah.
So the second question is on what is the feature importance metrics based? So what's behind the feature importance?
Okay, so for the feature importance, we use surrogate random forest models. So that means that we are training a random forest on the predictions of the model. So not on the ground truth data, but on the prediction of the models. So basically, we have a random forest that is overfitting also the misclassification of the models. And once you train a random forest, you're able to see how many times features is used to split a tree. And by using these metrics, you're able to rank the features this way. So that's what we use for the dashboard. But there are also other metrics that could be used.
Okay. So another question is, what libraries for machine learning are used here?
All right. So there is different libraries. We are using for certain nodes KNIME nodes, and for certain others also the H2O library. We have an integration with H2O, and we are using those nodes. And but you can also add more nodes if you want to use, for example, the Keras extension. We have ML4J, we have Tika. We just select some of them, honestly, because KNIME, we have many integrations, and we had to come out with a selection at some point. But definitely there are more possible model to add to that list. Yeah.
So people could download the blueprint and then add their own models.
Yeah.
Okay. Okay. So another question here is, do we have time? Yeah. You have shown a number of parameters that I can set, but what if I, even those parameters are too complex for me and I want to just run it without setting any parameters? Well, besides, of course, the file upload.
Well, thing is that you can just run the entire workflow, but the thing is that we can guess some things for you, some other things it's hard to guess, right? So if the problem is really simple, it might work, but for some other problems, you need to actually change those default options, like what column you want to predict, and this kind of stuff.
Okay. Yeah, there is a similar question. It says, so is it useful to completely automate the whole cycle then?
Well, that depends on the complexity of the problem. There are really simple problems that definitely can be automated, and that would be when it's really easy to find a connection between the column and what you want to predict. Some other times is a bit more difficult, and that's where you need the domain knowledge of the business analyst to do some really precise data preparation step. In that case, you might need to customize a bit more. So full automation is not always working, let's say.
Okay, so I have the last two questions. So one is asking which one is the best platform, if Jupyter or Python notebook, to use machine learning algorithm. Well, I mean.
Well, I think I'm biased here.
Yeah.
Well, thing is that definitely it depends. That's the question, right? Always depends on what you use. Definitely right now, Jupyter notebooks are quite popular, but also require a lot of skills to get them to run correctly, right? So by using KNIME, you can use our models, and you can also basically import and connect to a Jupyter notebook. That's quite new. But you can also connect to Python, to R, to Java, like anything that works for you probably works also in KNIME. So it really depends on where the data scientist finds himself more. It's more comfortable for the data scientist to work with, right?
Okay, so we have a few questions on how we can access the blueprint. I think we can put back the slide.
Oh, yeah.
But we can do it. So we have another question, the last one, and then we put back the slide with the path to the blueprint. When using the blueprint, will the uploaded data be stored in a public KNIME server or on a private KNIME server? Where does the data go?
Well, if you're using KNIME server, you're using your KNIME server. So it goes in a private one, right? So the upload of the data is always staying in your wherever you install your KNIME server. That could be your own Amazon Web Service, Azure, or even if you have a machine in the company, which is where the KNIME server is installed, right? Which is I guess, the most safe situation. So the data doesn't leave the company. And yeah, we don't worry, we're not gonna get your data this way.
It's not going on the cloud. So for this demo, for example, we used a KNIME server that was on this machine. So the machine had the local KNIME server and the local KNIME analytics platform. So everything was self-contained in this machine.
Yeah, but this was for testing. You could see that the address was localhost and not like an actual domain.
Right. So you can put it wherever you install your KNIME server.
Should we show on the example server? Where to access the blueprint?
So the next question is, and the last question, and then after that I think we are done, is how we can access the blueprint and where we can find it.
Let me share the screen again.
Or you can put back the slide where you were showing. Yeah.
All right. It should be a few slides back. Here.
Right.
So yes, so basically, if you don't know the example server, you should definitely have a look. You install the KNIME Analytics platform, and you have this example server, which is totally open to access and already connected. You just need to double click, and all those folders opens up, and you have a bunch of different workflows to different use cases and different set of nodes. And this helps to basically build workflow in KNIME. And at this location precisely, which is in the folder 50 and this 36 guide analytics for machine learning automation, you can basically just download from there this entire folder, and you have full access to the entire workflow. So that's it. You can find it there.
Okay, thank you. Thank you, Paolo. Thank you all for attending. I would like to say goodbye here. Please remember that the recording of this webinar will be available on this same link on YouTube, probably in 20 minutes or 1 hour or something like that. Give us the time to clean up a bit the video. Thank you very much, all of you, and I hope you have a nice rest of the day or evening or wherever you are located. Bye.
Bye, everyone.